Good afternoon, friends. Today I am going to the design of machine elements 1, third unit, design of riveted joints. Design of riveted joints. Data book, design data book, SMD Jalaluddin. Follow to the in this chapter riveted joints 10.1 page number to 10.24 page number. Okay. Next, design of riveted joint unit number 3, first part. Okay, na introduction to the riveted joint. Okay, this is a riveted part. Okay, tail part, shank or body, head. Okay, a rivet is a short cylindrical bar. A rivet is a short cylindrical bar with a head integral to it. Okay, with a head integral to it. And the body size is less than the head size. Okay, now the cylindrical portion of the rivet is called shank. Okay, the cylindrical portion rivet is called shank. Okay, or body, shank or body. The cylindrical portion of the rivet to shank or body, and the lower portion of a shank is known as a tail. The lower portion of the shank is known as a tail part. The lower portion of the shank or body is called tail part. Okay, as shown in the figure 9.1, riveted parts. Okay, the rivets are used to make permanent fastening between the plates, such in structural work, shipbuildings, bridges, tanks, and boiler shells. Okay, this is a permanent fastening and a permanent joint. Permanent joint is called a riveted joints. Welded joints are permanent joints. Okay, rivets are permanent joints. Bolts are temporary joints. And it is bolts are removed. Okay, bolts are removed to separate the two plates. Okay, now rivet are permanent fastening between the plates. Okay, next the rivets, the riveted joint are widely used for joining light metals. Okay, now the fastenings joints may be classified into the following two groups. Okay, fastenings two groups. First one, permanent fastenings. Next, temporary or detachable fastenings. Permanent fastenings and temporary or detachable fastenings. Okay, now next introduction. Okay, the permanent fastenings are those fastenings which cannot be deassembled without destroying the connecting components. Okay, now the examples of permanent fastenings order of strength are soldered, brazed, welded, or riveted joints. Okay, now permanent fastenings means cannot deassembled the male and female pieces. Cannot deassembled male and female pieces. That is called a permanent fastenings or permanent joints. Okay, now the permanent joints, the best examples are solder, soldered, brazed, welded, or riveted joints. These are the permanent joints. Okay, next the temporary or detachable fastenings. The temporary or detachable fastenings are those fastenings which can be deassembled without destroying the connecting components. Without destroying the connecting components. Okay, now next the examples of temporary fastenings are screw, keys, cutters, pins, and splined joints. These are the temporary or detachable fastenings. Okay na. The most difference between the permanent fastenings and temporary fastenings. Next, materials of rivets. Okay na. The rivets are used as a permanent joints or permanent fastenings. Which type of material are used in rivets? Okay na. The materials of rivets. The materials of the rivets must be through and ductiles, tough and ductiles. Okay na. The ductile materials are used as a rivets. Okay na. They are usually made up of steel, low carbon steel, nickel steel. Okay na. Usually made up of a steel. Okay na. First one is low carbon steel or nickel steel, brass, aluminum or copper. But then strength and the fluid tight joint is the main consideration. Then the steel rivets are used. Okay na. The steel rivets are used in which place fluid tight joints. Okay na. Fluid tight joints is the main consideration. The steel rivets are used. Okay na. Next, the rivets for general purpose small. The general purpose shall be manufactured from steel conforming the following. Okay, Indian standards. IS 1148 to 119 1982. Okay, 1982 specifications for hot rolled rivet bars. Okay, now hot rolled rivet bars up to 40 diameter for structural purpose. Okay, next, 1949 1149 to 1982 specifications are for high tensile steel rivet bars. High tensile rivet bars for structural purpose. Okay, this Indian standards. First one, specifications for hot rolled rivets bars up to 40 diameters. Next one, high tensile steel rivets bars, structural purpose. Okay na. Next, types of riveted joints. Types of riveted joint. Following the two types of riveted joints, depending upon the way in which the plates are connected. Okay na. Depending upon the way in which the plates are connected. Okay na. First, these are the types of riveted joints. First one, lap joint. Okay, a lap joint is that in which one plate overlap the another. One plate overlaps the another, and the two plates are then riveted together. And the two plates are then riveted together. Next one, butt joint. A butt joint is that in which the main plates are kept in aligned butting, kept in aligned butting and touching each other, and a cover plate is placed either on one side nor on both sides of the main plates. Okay, now the cover plate is then riveted together with the main plates. Okay, now next, butt joint. The butt joints are following two types. First one, single strap butt joint. Next one, double strap butt joint. In single strap butt joint, the edges of the main plates but again each other, and only one cover plate is placed on one side. Okay na. Of the main plates, and then riveted together. Okay, single strap butt joint means one plate. Single strap butt joint means one cover plate is placed on one side. Okay na. One side of the main plates. Okay na. Double strap butt joint. In a double strap butt joint, the edges of the main plates but against each other, and two cover plates are placed on both sides. In double strap butt joints, two cover plates are placed on both sides of the main plates and then riveted together. Okay, now this is a double strap butt joint. Okay, now the main difference of the single strap butt joint and double strap butt joint in this video, in this projector. Okay, now next, riveted joints. In addition to the above following the types of riveted joints, depending upon the number of rows of the riveted number of rows of the rivets, single riveted joint. A single riveted joint is that in which there is a single row of rivets in a lap joint as shown in figure 9.6a, and there is a single row of rivets on each side but butt joint as shown in figure 9.82. Double riveted joint means a double riveted joint in that in which there are two rows of rivets in lap joint as shown in figure. Okay, now this is the riveted joint. So first one single riveted lap joint. Okay, now first one single riveted lap joint. Next double riveted lap joint chain riveting. Okay, number of holes are different. Next double riveted lap joint zigzag. And the holes are zigzag direction. This is the most important the difference of single lap joint and double riveted lap joint and chain riveting or chain riveting and double riveted lap joint zigzag riveting. Okay, now next the important terms used in riveted joints. Okay, now the important terms used in riveted joints. The important terms P, PB, PD. This is the important terms of riveted joints. Okay, now first the important terms pitch. It is the distance of the center of the one rivet to the center of the next rivet measured parallel seam measured parallel to the seam as shown in figure 9.6. It is usually denoted by P. Okay, this is the P as shown in figure. The difference between the one rivet hole to another rivet hole. Okay, now the distance of the center of the one rivet to the center of the next rivet measured parallel to the same. Next, back pitch. It is the perpendicular distance between the center line. It is the perpendicular distance between the center lines of the successive rows as shown in figure. Okay, now successive rows. It is the perpendicular distance between the center lines. It is the perpendicular distance between the center lines. Okay, now PB back pitch. Back pitch. It is a perpendicular distance between the center line of the successive rows as shown in figure. It is usually denoted by PB, diagonal pitch. It is the distance between the center of the rivets in a adjacent rows of zigzag riveted joint. Zigzag riveted joint. It is usually denoted by PD. Okay, next margin or marginal pitch. It is the distance between the center of the rivet hole to the nearest edge of the plate as shown in figure. Margin or marginal pitch. Okay, now it is denoted by M. Next, caulking. Okay, now caulking. It is the most important in 2 marks, caulking. Okay, na? Caulking. In order to make the giant leak proofs or fluid tight in pressure vessels like steam boilers, air receivers, and tanks, etc. Okay, na? Caulking. It is a caulking tool. It is a caulking rivet tool. Caulking tool. Okay. In this portion is two different mating parts. Caulking rivet and caulking tool. It is a leak-proof joint. Leak-proof joint or fluid-tight joint. A process is known as caulking is employed. Okay. In this process, a narrow blunt tool called caulking tool, about 5 mm thick and 38 mm in breadth, is used. The edge of the tool is ground to an angle 80 degrees. Okay, na ground to tool angle is 80 degrees. The tool is moved after each blow along the edge of the plate. Okay, which is planned to a bevel of 75 degrees to 80 degrees to facilitate the forcing the forcing down of edge. It is seen that the tool bursts down the plate at A. Tools burst down the plate at A. As shown in figure 9.12a, forming a metal to metal joint. In actual practice, both the edges at A and B are cold. The head of the rivets, as shown at C, are also turned down with caulking tool to make a joint steam tight. Okay, now this is the caulking. Caulking is the most important joint of fluid leak and fluid tight and leak proof joint. Okay, na? Next, furring. Furring is the another type of leak proof joint. Caulking is a the tool, cowling tool. Furring is a the tool, furring tool. Okay, na main difference of the caulking and furring. A more satisfactory way making the joints such stack is known as furring, which has largely suppressed caulking. In this case, the furring tool, which a thickness at the end equal to that of the plate, is used in such a way that the greatest pressure due to the blows occur near the joint, giving a clean finish with less risk of damaging the plate. A furring process is known as figure 9.12b. Okay, now this is the furring. Next, failures of a riveted joint. Different types of failures are having riveted joints. The first one, tearing of the plate at an edge. Tearing of the plate at an edge. A joint may be failed to tearing of the plate an edge, as shown in the figure. This is the tearing of the plate. This can be avoided by keeping the margin. Avoided by the keeping the margin m equal to 1.5 d, where the d is the diameter of the rivet hole. D is the diameter of the rivet hole. P is the pressure force. Forces are applied to the both sides of the rivet. This is the margin. The center distance between the outside of the plate. This is the margin. Okay, na? The margin m equal to 1.5 d. D is the diameter of the rivet hole. Okay, next, tearing of the plate across a row of rivets. Across a row of rivets. This is the cross a row of rivets. Due to the tensile stresses in the main plates, the main plate or cover plate may be tear off across a row of rivets, as shown in figure 9.14. Tearing of the plate across a rows of rivet. In such cases, we consider only one pitch length of the plate, since every rivet is responsible for that much length of the plate only. Next, the resistance offered by the plate against tearing is known as a tearing resistance or tearing strength or steering value of the plate. Okay, now next, failures of a riveted joint. Failures of a riveted joint. Let D equal to pitch of the rivets, D equal to diameter of the rivet hole, E equal to thickness of the plate, next sigma T equal to permissible tensile stress for the plate material. We know that tearing area per pitch length, okay, AT equal to E minus T into T. AT equal to E minus T into T. Tearing resistance are pull required to tear off the plate per pitch length. Okay, now PT equal to AT into sigma T equal to P minus D into T into sigma T. The tearing resistance are pull required to tear off the plate per pitch length. Okay, now when the tearing resistance PT is greater than the applied load P per pitch length, then this type of failure will not occur. Okay, now failures of a riveted joint. Next, failures of a riveted joint. Third one is shearing of the rivet. The plates is connected to the rivet exert tensile stress on the rivets, and if the rivets are unable to resist the truss, there are sheared off as shown in figure 9.15. It may be noted that the rivets are single shear in lap and a single cover butt joint as shown in figure. The butt rivets are double shear in a double cover butt joint as shown in figure. Okay, the resistance offered by the rivet to be sheared off is known as shearing resistance or shearing strength or shearing value of the rivet. Shearing value of the rivet. Okay, now next, the failures of a riveted joints. These are the shearing of rivet in a lap joint, shearing of rivet in a lap joint. This is the two mating parts of the rivet hole. The shearing of the riveted joint. This is the single shear of rivet in a single cover butt joint. Single cover butt joint. Next, B equal to diameter of the rivet hole. Tau equal to say permissible shear stress of a rivet material. N equal to number of rivets per pitch length. Okay, now next, failures of a riveted joint. We know that shearing area A is equal to pi by 4 into d square. Okay, in a single shear, 2 into pi by 4 into d square, theoretically in a double shear, 1.875 into pi by 4 into d square in a double shear, according to Indian boiler regulations. Shearing resistance are pull required to shear off the rivet per pitch length. Okay, PS pitch length n into pi by 4 into d square into tau in a single shear, n into 2 into pi by 4 into d square into tau theoretically in a double shear, single shear, double shear. Okay, n into 1.875 into pi by 4 into d square double shear according to the Indian boiler regulations. When the shearing resistance PS is greater than the applied force, the shearing resistance PS is greater than the applied force per pitch length in this type of failures will occur. Okay, next, fourth one, the crushing of the plate or rivets. The crushing of the plates or rivets. This is the fourth one failure of the riveted joints. Sometimes the rivets do not actually shear off under the tensile truss, but are crushed as shown in figure. Okay, sometimes the rivets do not actually shear off. Okay, due to in this the rivet hole becomes an overall shape and hence the joint becomes loose. The joint becomes loose. The failure of the rivets in such a manner also is known as bearing failure. The area which rivets this action, the projected area of the hole are riveted on diametral plane. Okay, the resistance offered by a rivet to be crushed is known as crushing resistance or crushing strength or bearing value of the rivet. Okay, these are the values of the rivets. Let D equal to diameter of the hole. Next, D equal to thickness of the plate. Sigma C equal to say permissible crushing stress for the rivet plate material. Next, N equal to the number of rivets per pitch length under the crushing. Okay, now we know that the crushing area per rivet AC equal to dt. Total crushing area equal to N into D into T. Next, crushing resistance are pull required to crush a rivet per pitch length. PC equal to N into D into T into sigma C. When the crushing resistance PC is greater than the applied load P, and the length, this type of failure will occur. Okay. Okay. In this section is closed to explain the failures of the riveted joints.